Okay, let's talk about the three states of matter. I'm not going to focus so much on the operational and conceptual definitions. I'm just going to give you an overview. There are three different states of matter: solid, liquid, and gas. In terms of their shape and their volume, solid has a fixed shape, okay? And it also has a fixed volume. You will sometimes see this referred to as a definite volume, okay? You cannot compress a solid because it's already as tightly packed as it could possibly be. In terms of motion, you will only have the particles vibrate or oscillate in place. Okay? And then solids tend to have the lowest kinetic energy. In terms of liquids, liquids take on the shape of their container. So that means they actually have indefinite shape, but they do have a fixed or definite volume. There is a little bit of space in between the liquid particles, so that means liquids are technically slightly compressible. Okay? And then in terms of their kinetic energy, they would have more kinetic energy than solids. Okay? Because they can slide over each other. They've got a little bit more motion. In terms of gases, gases take on the shape and the volume of their container. So that means they have both indefinite shape and indefinite volume, okay? They will have the highest kinetic energy of the three states of matter because the particles can randomly move and collide with each other, okay? Let's go to the next page. On the next page, they talk about the kinetic molecular theory. This outlines what happens to matter when their motion changes. So kinetic molecular theory is often abbreviated as KMT. I would know that. You will likely see a question on a test related to this. The key points are matter is made of particles. There is empty space between particles. Particles are always moving. The amount that they move depends upon what state of matter that they're in. And then particles move because they have energy. And the amount of energy they have determines how fast they're going to move and how far they will move from each other. Okay? When we're changing between the three states of matter, there are different terms which are pretty much everyday terms that you guys have heard before. So let's come down here to these terms, and each one of these terms is going to be associated with either removing heat or adding heat, okay? So on the right-hand side of this image, we are going to be adding heat. So we're going to be converting a solid to a liquid, then to a gas. So when you're melting something, you have to add heat. So that would be converting a solid to a liquid, evaporating as a liquid to a gas. Sublimation is where you never go through the liquid phase. It goes from a solid to a gas. And this is what dry ice does. Dry ice is solid carbon dioxide. Okay. On the left-hand side of this figure, this is where we would be removing heat. So if I convert a gas into a liquid, heat would be released. That's condensation. Liquid to solid, that would be solidification. Gas to solid, and then it bypasses the liquid phase. This would be deposition. A couple things that I would know up here is that evaporation is also known as vaporization. I would also know that the right-hand side of this figure, anytime you're adding heat, that means these are endothermic processes. And then on the left side of this figure, removing heat, So heat would be leaving. These would be exothermic processes. Okay, and then turn to the next page when you're ready. We're almost done with this section. This entire page is about melting point and boiling point. I'm going to highlight some of the things that I think are important, but you probably want to read through this later. Melting point is the temperature of a solid as it changes into a liquid. This happens because the particles can spread apart and slip through the gaps. So melting point depends on how strong the particles are holding on to each other. So like intermolecular forces, like hydrogen bonding, for instance, as well as what's the mass of those particles and are they symmetrical, okay? Most of the time, the freezing point and the melting point are going to be the same. Melting point also has another definition. So melting point is also described as the temperature at which a solid is immersed in its own liquid. Okay, and then let's go on to boiling point. Boiling is a special case of evaporation. Okay, so if there's a puddle of water outside, you know that eventually that entire puddle will evaporate. And boiling happens when we have vigorous bubbling within a liquid and then it internally vaporizes. So typically what happens is if we're heating a pot of water on a stove, the heat is going to hit basically the water molecules that are at the bottom of that pot first. It will cause their kinetic energy to increase. It will rapidly move and collide with each other and create space in between the water molecules. And then what happens is a bubble can form and then water molecules can escape within that bubble. They rise to the surface and then you can have your water vapor above the liquid, okay? All of that is sort of described within this reading. And then let me come down here and I want to highlight a couple of other things. There's another definition for boiling point, and it's related to the vapor pressure of a liquid. So the temperature at which the vapor pressure equals the surrounding air pressure is when something will boil. So I can actually take a beaker of water, put it in an airtight container, drop the pressure above it, and make it boil at room temperature. Okay, so that's showing you that the vapor pressure, as long as it equals the air pressure above it, it will make something boil. Okay, and then so that's why when you go up to the mountains, the atmospheric pressure drops in the mountains. Think of it as like there's less particles above you in the mountains. So if the air pressure drops, the vapor pressure of water doesn't have to be as high, and that's why water boils at a lower temperature up in the mountains. Boiling point is also defined as the highest possible temperature in the liquid state at any atmospheric pressure. Okay? Let's take a look at the next page. Let's talk about volatility. Volatile liquids are not explosive liquids per se. We don't really refer to them that way. Volatility has to do with how readily something will evaporate and just go into the gas phase, like right away. So boiling point, vapor pressure, and volatility are actually closely related. So if something is volatile, it will readily evaporate or evaporate at a really high rate. Volatile substances have high vapor pressures because there's a lot of them in the gas phase, and then they have low boiling points. So let me give you some examples of volatile substances. So things that you can put on your skin that evaporate right away and generally feel cool would be volatile. So rubbing alcohol or acetone, which is in nail polish remover, and then gasoline are good examples of volatile substances. Okay. Let's talk about heat of fusion and heat of vaporization. And then I've got to talk about one more thing and then we're done. Okay. Okay. If I'm trying to melt something at its melting point, I have to put some amount of heat energy in. This is called the heat of fusion. Okay. So just to sort of like give you an example of what this looks like, if I'm converting a solid into a liquid, heat of fusion is typically abbreviated. They usually put a triangle with an H and a little F or a little FUS to represent fusion. Okay. So you would have to put that in. So that would enter here. If you're trying to melt a solid into a liquid. Okay. And this is the difference in potential energy, which is stored energy between the solid and the liquid state. Okay. And potential energy is something I haven't mentioned yet. Potential energy is stored energy. Typically, this is abbreviated as PE. Stored energy in chemistry is typically going to be in bonds. Also, you can have stored energy like the proximity of electrons to protons in atoms. Also an example of stored energy. Okay. If I'm converting a liquid back to a solid, so let me do that over here. I'm going to be releasing the heat of fusion, whereas up here, we were absorbing it. Okay. And then lastly, heat of vaporization. This one is involved in converting a liquid into a gas, for instance. Okay, so the amount of heat it takes to evaporate something at its boiling point, this is usually abbreviated as a triangle with an H and a little VAP for vaporization after it. Okay, so if you're going to take a liquid and convert it into a gas, then you would have to have the heat of vaporization absorbed like this, versus if I was converting a gas back to a liquid, this would release the heat of vaporization. The units for both of these are typically in joules per gram. You typically are given those values in a table as a reference, and I believe they're on the next page. Let's go to the reading the heating curve, and then we'll look at the last page, and we'll finish this by 11, okay? So let me stop this video.